Okay, we want to sketch each angle, cross out in the directions reference angle there. So sketch each angle, then mark and find its reference angle. So there's a little bit of cleanup on the directions there I should have had. So we're going to start off with sketching the angle. So to sketch the angle, this thing is a 480 degree, and I know in one rotation there's 360 degrees. So I've got to go 120 degrees past one rotation. So here's where we start. We start on the origin. Our initial side is on the positive x-axis. If it's positive, like this one is, we rotate counterclockwise, one full rotation, that's 360. Then I want to go another 120 degrees, well that's 90, and I got to go 30 past 90. So there's the representation. Now I'm going to draw the reference angle. So this terminal side right here marks out the 480 degree angle. But we want the reference angle, and the reference angle is always situated between the x-axis and the terminal side of your angle. So that's what this angle is. So since we went 120 degrees, we are 60 degrees short of the 180 mark. So 60 degrees is your reference angle. That's one of the things we're looking for. And the second example, what we've done is we've changed to reference our angles in radians and also went in a negative direction. So a negative direction makes us spin clockwise instead. So we're going to be going clockwise. And in radians, what we did is we said we're going to make sure that we take this denominator and write each of these axes, our quadrantal axes, in thirds. So we're going to start with 0 pi thirds. In a standard position, our angle starts with its vertex on the origin. The initial side is on the positive x-axis, and we know we're going to rotate counterclockwise. Well, if I go halfway around, that's pi, that's equal to 180 degrees. I'm just writing an equivalency, but pi is 3 pi thirds. So 3 pi thirds is halfway around. All the way around one time would be 2 pi, and I want to write it in thirds, so now I'm going to get rid of these two descriptions, and I'm going to make it 6 pi thirds. Okay. So basically every half a rotation is a pi third, so I'm going to start rotating around this and describing what I'm going to do with this. So we're going to start on the positive x-axis. We're going to go 3 thirds, 6 thirds. Now I'm at 9 thirds. If I came up to here, that would be 12 pi thirds. So I don't want to go quite that far, so I want to stop there. If that's 9, 10 pi thirds is sitting in this second quadrant. So that's the end of that terminal side. Now we're going to find the reference angle by going from the x-axis to that terminal side. If that was 10 pi thirds, if we rotate it around, there's 3, 6, 9. That's only a pi thirds beyond that. So pi thirds is your reference angle.